Well, so there's really three parts to that. What we'll do initially is we'll come up with a design concept. We'll take that design concept and we'll begin to develop in our computer-aided drafting software. And we'll develop 2 or 3 different models for that, and we'll refine the models to the point where we can begin to load them into our finite element analysis software. So once we get to the point where we can do that, we can look at the finite element analysis model after we've run it to the loads we expect to see, and we can start to see stress risers and stress areas where we're worried about. That allows us to take that design, refine it, run it back through our CAD system, make changes to the deck, then rerun the finite element analysis to the point where we're happy with the design, to the point where it's going to meet our criteria if it performs that well. Now here's where Mettler-Toledo differentiates itself from all of our competition. We've taken the time and the effort, and a lot of money too, and we've built a test fixture out in our lab that allows us to apply over 100,000 pounds in the same model that a dual tandem axle load would be applied in the field. So now we have this model in our CAD system, we have the finite element analysis model, we also have a bunch of engineering calculations that we've probably done by hand or we've used software to develop too. But now we take that and we make it real. We build a full-size model of the modular system that we've developed, the scale structure, whatever we're doing, and we take that full-size model and we put it in our test fixture. Then we apply a load to it of whatever we decide the rated load is going to be, and we cycle that load over 1 million times for every module that we're testing. Now during that time we'll move the dual tandem axle setup to 2 or 3 places on the module to replicate different loading patterns, but we end up with 1 million, 1.5 million, maybe 2 million cycles before we decide, hey, that's enough. Now during that period, we might see something we don't like because at the same time, we've been running strain gauge analysis on it, we've been checking the welds for cracking, we've been doing a lot of other things, measuring the deflection. It's another one of the subjects on these videos. So we'll take that model and we might decide, hey, let's just scrap this, build a new model, put it in the masher. But it has to meet all of our design criteria, it has to do everything that we expected it to do before we say it's okay. And to kind of back that up, globally Mettler-Toledo has built 50,000 scale units using the orthotropic rib design. So we know what works, but we still have to empirically test it.